Hello and welcome to the FlowCAD webinar, Efficient Data Management in Electronics Development. In the next hour, you will get an overview of the various data and interfaces that play a role in electronics development. We will show you the main functions of our data management solution, OMNYA Integration Platform. My name is Petra and I'm supporting my colleagues Holger and Tomasz. A few words about them. Holger studied communications engineering and has many years of experience in PCB design for various applications, as well as design flow development and support. He has been an application engineer at FlowCAD for 7 years. Tomasz is manager at FlowCAD Poland and takes care of the Eastern Europe sales region for long years. He and his team are largely responsible for the development of OMNYA. That's all for the moment. So Holger, let's get started.
So what are we going to talk about in the next hour? First of all, why are we going to talk about that? So in electronic development, all of you guys know, we have a bunch of information, huge mass of data coming from different sources, and everything is constantly changing somehow. So new parts are introduced, parts get end of life. You get different information from the different systems. For example, the manufacturing data out of a PCB design system, data from web interfaces or something like this, and everything needs to be collected somehow. So, and this is exactly what we are going to do here. There's also often the need for some temporary data in the development flow or something like this. And yeah, you want to collect all this, but you don't want to necessarily upload everything into a PLM system or something like this, because lots of this information are not needed in a later point in time in the design cycle. So, and therefore we have invented at FlowCAD OMNYA, a complete data management solution in the end. Also, not just data management, but also including library management. And this is somehow a differentiator, I would say. So we are not handling just part information like the value, manufacturing order code, or these kind of things, but also all the library data, all the manufacturing data, and also we can also save a board file or something like this inside of OMNYA. So, and then we have a standardized information and can upload the system which are really required into the PLM system. So, and yeah, also nice and clean user interface. Tomasz will show this later on inside of the tool. But let's first have a look at this different data we are talking about, and also have a look at the different people involved inside of the PCB design process. So I will not read through all these points, just mention a few of them. So first, having a look on the right side. So there we have, for example, the schematic engineers. So they for sure need their schematic symbols, they need simulation models, need the data sheets and all these kind of things. Also PCB designer, they need their footprints, they need to get some rules, also need the data sheets, maybe also need standardized cross sections or something of the different boards from different vendors. Yeah, and all these kinds of information are actually stored in OMNYA then in the end. So, and who's providing different informations? Basically the same people here. So schematic engineers for sure sets up the constraints, draws a schematic, creates the BOM and these kind of things. And the BOM is then again needed by the production to manufacture all this stuff. So, and you see, by this, OMNYA helps you to collaborate inside of your team. So it's easier to get the information. We will have a look at the benefits of the system a little bit later here. So, and how are we going to do this? So we have basically one central system. This is this OMNYA database here in the middle. And this is collected to all the other systems and gets information from all the other systems and different sources here. So here on the bottom, we have really the fundament, I would say, for our day-to-day work. So the PCB design tools and PCB design tools, they get information in forms, for example, of the libraries, which are saved in OMNYA and get the parts from there. So symbols, footprints, 3D models, and all these kind of things. On the other hand, these PCB design tools, they provide data into OMNYA, like the BOM, like Gerber data, drill data, IPC 2581, whatever. And this information can also be saved inside of OMNYA. And then we have these web interfaces here, for example, for the or to the content provider like Ultra Librarian, like SiliconExpert, also to the distributors and these kind of things, and fetch information from these from these sources, not to fill in everything by hand or something like this. So, and this we have an online connection to these systems, and therefore OMNYA has always up-to-date information here. So, and then if you want to exchange, so this is a closed system, so to say. You can use it use OMNYA, so to say, as a data management system, but you also have the possibility to exchange information with the PLM or ERP system, so like Windchill or Teamcenter or Arena or something like this. This is also possible by this open API interface. So, and then also you can give back information into the PLM system. So yeah, this is basically the setup of OMNYA, or an overview, I must say, so that you have an impression of the different interfaces we are talking about. And Thomas will show this a little bit later inside of the tool, how this interface of OMNYA, especially this web interface, looks like, and how you, for example, set up parts and these kind of things. So continuing with the overview here. So basically we have three parts here of OMNYA. So the first thing is the part management. So this is in the end mostly the metadata of the different components. So we can, for example, use the search provider, have parts revision for sure, alternative parts and so on, can handle the end-of-life information, product change notification, and these kind of things. And we also have a small flow inside there, so for ICE principal flow, to do the release of new components. And this is also the same here for the library management. There we also have the similar 4i principal flow. And yeah, here inside of the managed central library can save for sure footprint, schematic symbol, and all these kind of things. Can also support various PCB design tools in case this is somehow necessary. And what is really interesting, there's a where used report possibility. So you can have a look what is used where. So for example, what pad stack is used in what footprint, and also can have a look at which parts are used in which different designs. So, and this is really a nice thing, because in case something is wrong with the footprint or with the pad stack or something, you simply see where it is used and what you need to change to get rid of some problems here. So, and then we also have this project and BOM management stuff. So handling revisions of the different projects. We can have a look at the different variants of a design, and also team collaboration, because everyone can access this data and fetch the required data from OMNYA, which is needed for his work. Good. Maybe closer look at part management. In the end, this is, as I mentioned, mostly the metadata of the components. So, and we have here this connection to the distributors. We for sure can set up alternative parts. So, for example, different vendors for a capacitor or something like this. And we also have a nice possibility to define assemblies here. So imagine you have a transistor, and this transistor needs a heatsink, needs a screw for the heatsink, and needs some thermal paste or something like this. Then you all have to have all of this inside of your BOM, because the transistor on its own is not sufficient. So, and by this setting up these kinds of assembly, you are sure that you won't forget, or the purchase guys won't forget anything here. So, and this is really a nice and important thing, so that you in the end have a complete BOM with all the things required for your design, for your PCB or your module to work in the end. Good, and also you can have a look here, or can handle different parts revision, and the purchase guys can also inform the other people involved inside of the design process regarding product change notification or even end of life of something, or some these kind of information basically. And what's also nice, there's a dashboard, and inside of the dashboard you see what actions are required by you. So this is also a nice thing. I guess Thomas will also show this later on inside of the user interface of OMNYA. So much about the part management for the moment. Then, as I mentioned, we also have the possibility to do library management here. So, and what is most important here, I would say, we have a central library and we have local synchronized copies of the library, and people working with the PCB design tools, they use their local copy to work. So, and this avoids completely the latencies between one very far away server location or something like this. So, and this is really important. I mean, if you know the day-to-day work, and if you always have, when you place a schematic symbol or something, a latency inside of your tool, then it's really cumbersome thing to work. So, and therefore, this is really a good thing to have these local copies of the library, which are completely synchronized with the central one. So, and in the end, yeah, we can handle all the A data, pad stacks, footprints, schematic symbol, and so on and so forth. So, and also we can have this where used thing. I will show this on the next slide. Also, we support all tools basically. So, focus for sure for us is the Cadence Tools, but we can also support Altium, eCAD, and so on. So, here's a nice picture of this where used functionality, I would say. So here, what we see here pad stack, TH1, whatever, which is used in this footprint SMB90. And then again, this footprint SMB90 is here in this case used in our FlowCAD demo design, Flex demo design 4 times. So I used here the step models or pictures of the step models because it's nicer than just a stupid footprint drawing. So that's why I used this here. So and yeah, this is really a good thing. So imagine if pad stack is wrong, too small annular ring or something like this, which needs to be corrected. Then you can directly see where this is used and what footprints and where you might get problems with this. With this pad stack here in the end. So, and this same thing is here also possible for projects. So you can see in what projects these SMB90 connector is used, for example. So, and get a report. This is also interesting, for example, if you think of end of life or something, then you can directly see, okay, here I have these 3 projects here where an end of life part is used. And yeah, I have to keep this in mind and maybe redesign these products to use a different component for the end of life one. So in addition to this, we also have the storage possibility of basically all design data you can imagine. So you can save schematics, can save layouts, Gerber data, manufacturing data, also all the documentation stuff and so on and so forth. So basically everything. And also revision everything. So, and by that you can use your own numbering scheme, or this can also be controlled by the PLM system, which you might already have inside of your company. Good. So much about this BOM management. So I already talked a little bit about the benefits, and here, an overview about the different people involved inside of the design flow. I will again not read through this complete slide for sure. Just like some examples. So what's the benefit, for example, here for the schematic engineer? I mean, yeah, it's obviously he directly gets all the required informations. Don't need to look up in the internet for some data sheets or something like this. Has all the information on its hands inside of one system, and this is basically the same here for the PCB design guy. He has direct access to the libraries, to data sheets, to templates or whatever. So, and then yeah, this is really a nice thing because all of you guys know how cumbersome this sometimes is to get the right information, to get the right data sheet, to keep all these things also up to date always. This is also sometimes really a tough job. So, and yeah, the OMNYA makes your life a little bit easier here, hopefully, by directly providing the right information in one location, basically. Good. So much about the different people involved in the design process, I must say. What is the key benefits of the system overall? So it's easy to install. That's the first thing. You can directly run it in the cloud. You can install it on premise in your machines. It has this open API stuff to connect to the PLM systems. And it can then also work as a preprocessor for the data you want to upload into the PLM system, because as I mentioned, not necessarily everything is required to be saved inside of the PLM system. And this is really a good thing. I mentioned this library synchronization process. So you always have a synchronized, up-to-date library saved locally somewhere. And by this avoid completely the latencies to a faraway server location or something. We have this dashboard to see all the information on one screen basically, and also see directly what parts need your attention or what you need to do next. So and then we have this very simple workflow, 4S principle workflow. So one guy is creating something, other guy is checking it and releasing it. So we really keep it simple, I must say. So this is really a simple 4S principle workflow inside there. So in the end, yeah, for sure, you will have a better library by that. You will increase the quality, no double parts. You always use approved and preferred parts, and everything is always up to date. And this is also really a good thing. So you're not working on an old, outdated library or something like that. Good. So much about the key benefits here of this system. Then I would like to hand over to you, Tomasz, so you can show us some of the features directly inside of the OMNYA system.
I will start with dashboard. Dashboard is the place where we can see a lot of information in simple form, easy to read form. So we have pie charts, we have tables. Depending what you need, we always try to display this information in the way it's clear for you. For example, here I have pending libraries. I will talk about libraries later, but here simply I can see that there are 21 PCB library objects which now are pending. Somebody is working on them, including me. Another very important widget is this one, My Task. This is where I can see all tasks which are assigned to me. They may be assigned to me by somebody else, because maybe somebody accomplished the first stage of creating of the new footprint, for example, and I am the one who should approve. But also here I see things what I started working with. So every time I am starting to create new part or new library footprint, for example, I will always find it here. It's very useful because even if I forget where the part is stored, from here I can very fast access. I'll just show you. So let's say this part with double click, I'm immediately redirected to this part. But dashboard is something what I will show you several times during this session. And now I would like to focus on those three management areas what OMNYA is offering. So we are managing parts, we are managing libraries, and projects. So those three areas very tightly connected to the design process are covered in OMNYA. So let's start with parts. So for those of you who are using today ORCAD CIS option, probably this view what I am presenting now is very similar to this what you see in ORCAD Capture CIS, because on the left we have some categories. And of course, we have the main table where we can look for parts. We can check the status of the part and also see other important information. So start with those information. If I select, for example, the capacitors, first of all, you can see that some of those capacitors are active, some other are pending, some other are active and used, and at the same time, now I will tell you what does it mean. But basically, if part is active, the active part is exposed to CIS browser. So simply the part is visible in OrCAD Capture CIS. If you are using HDL, Design Entry HDL, the another tool from Cadence, then only those active parts will be written into physical part tables, PDF files. So that's the same rule. As long as the part is pending, we don't write this, we don't expose this part. Okay, so let me click on the first capacitor, which is the active. Okay. So here on the, not this one, for example. So you see more information about this part here in the right panel. So you see how it looks like physically. So this is picture what we are collecting from distributors. So if we have assigned manufactured part number, real part number to this capacitor, and if distributor is offering the picture, we simply save the picture and we are able to display this picture here. By the way, very important thing what I didn't tell you. What you see here is the web interface. So this is just like web page. Okay, so it means everyone, even those who do not work with CAD tools, are able to use this. Yeah. And also those people can see how the schematic symbol looks like, how the footprint symbol looks like. This is everything available, even for people who do not work with CAD tools. So if I would like to define another capacitor, and I know that capacitor is using this schematic symbol, and for example, is using 06, 03 footprint, I will be able to create a new part in OMNYA, even without touching OrCAD PCB editor or OrCAD Capture, and also HDL front end, because also we have here schematic parts for HDL. We can keep in OMNYA different footprints, different schematic symbols. It's not only work with OrCAD, it also opened for other eCAD systems. Okay, so that's the first thing, the quick view, where we can see a lot of useful information about the part. Another thing is we have sometimes parts which are active and used, like this. What is the difference? We know that this part is used in one or many projects. And if I want to check where exactly the part is used, I have to click on this Where Used tab here, and I get the list of many of our test project, let's say. So what I can learn from here is that this capacitor is used in the project number 111123, in the second revision of this project, and in variant BOM core, and 3 of those capacitors are used in this project. And also another revision of this project, another maybe variants. So if we see that the part is used in any bill of material or in any variant bill of material, we will be able to display this information here. So that's the list of the all project. Here we also see what is included in this part. This is very useful information, because this part, of course, is using some schematic symbol, some footprint, and everything is listed here. So I know the name of the footprint, I know the name of the schematic parts. In this case, we have 2 for OrCAD Capture. Even I see the pet tag which is used. And if I am using HDL flow, I also see the name of the cell for HDL symbol. So not only where this is used, but also what is inside of this part. So the full list. We will use this information later for where use on the schematic, on the library level. Okay, so this is more or less, no, this is not everything. We also see that we have some manufactured part numbers, which are real parts which are assigned to this capacitor. you can see the difference. The capacitor in the main table is described using the typical capacitor electrical attributes, like the capacitance or voltage and the name of the footprint and so on. But here on the right, we see the real parts which are assigned. We have 5. I can assign more. So if I go to external search, I can simply look for other parts in Mauser, Arrow, Digikey, and so on. But let's back to the manufacturer part numbers. Here to the list, you see also that we have status with overall risk. This information is obtained from SiliconExpert. So if you have a contract with SiliconExpert, you can also get this information here in OMNYA interface. So for example, if this capacitor has high risk, I can click on that and look why the risk is high. Okay, we see this is only one distributor, probably estimated 1 year to the end of life. So there are many reasons to get low rank here, and the overall is like 52% for this part, which is really high. So the risk is very high. We also have here information about the life cycle, and also we have all those attributes which SiliconExpert is offering. We can see the long list of them here. Also, I have scrolled down a little bit, and a part of the price information. You see, we have the price with different ranges. So this is usually what you see when you're buying part using Mauser or Digikey or Arrow. So of course we are we see this information also in OMNYA, including also the availability and the lead days. But here below, the long table is the long table of attributes which are obtained from the SiliconExpert. So that's a very long list. Of course, we don't show everything graphically like here, but if you're interested, you can always check it. But again, this is not for everyone. You have to have contract with SiliconExpert first. Okay, so that's about manufacturer part numbers. We're talking about wear use. Okay, so I told you more or less everything about the parts, and we have different type of parts. We have electrical parts, so everything what is exposed to OrCAD capture, for example, what you can place on the schematic part, those parts are electrical parts. But we also have mechanical parts. We have, if I click here, we have some screws, for example. We have some probably some heat sink, everything what is mechanic. We have also software, so you can keep here the different version of the software firmware, whatever you need. We have also handling. Handling is very interesting type of part, because this is just extra minutes or what you need for the assembly process. So imagine you have some MOSFET capacitor which needs to be placed together with heatsink. Also, you have to provide the screw, maybe some glue, whatever. This is process which costs extra money or extra time, and those things can also be part of the final bill of materials, where you can see not only electrical parts, not only this what is exported from OrCAD capture schematic, but also additional mechanical parts, tasks which are here in the handling. So a lot of things. So under your imagination is limited. And this is also used in something what we call assembly. So if we go to this part, for example, or this one, you see this is basically this is MOSFET capacitor. It's main here, but a part of this capacitor, we have a screw, we have heatsink, we have some handling, so maybe a few minutes. But if we place on the schematic just this MOSFET, and if this MOSFET is using the this ASM SEM 002 part number, it means for OMNYA you are virtually placing all those other parts together with this capacitor. Sorry, with this transistor. You will not see this on the schematic, but later, if the bill of material is imported back in OMNYA, we will be able to extract this information and show you. So this is about the different part types. And of course, now what you can do. What does it mean, manage parts? Manage part means you want to create a new part, you want to change existing part, you want to maybe remove some part from the system. So how you can add the new part? Very easy. You can just click new, and you have the long tables, and all those attributes, of course, are optional, are for you. What we have here are only our examples. So don't worry, you can have your own. So that's the first thing. But this way of creating new part is very tedious, because you have to fill the long table. Of course, not everything. You can define what have to be filled. For example, when you started with some new part request. So with this icon tag request, we see that we have to provide value and we have to provide type. With those two attributes, we are good to start the new request. But again, this is a very tedious way. Another thing is you can simply click on the existing part, and with derive, we are copying all those information from the sourced part, and we are displaying all those information here, and you can simply change some attributes and save the information as completely new part. And here I will show you how we work with our libraries. So, for example, footprint, that's good candidate always. So if I click on the select from list, I get the list of all footprints which are already defined and verified in OMNYA. So this is the list from, I can choose whatever I want, and I am sure this is something what was already verified by somebody else probably, and I am very safe when I decide to use anything from this list. So let me search for some capacitors. If I will click here, select, you will see the change here. Yeah. So the very easy way. Another thing is, if I don't have existing symbol, I can also try to look at Ultra Librarian. Ultra Librarian is always connected to OMNYA. So this is not something what you have to buy separately, like SiliconExpert Access. I mentioned that SiliconExpert required a separate contract with SiliconExpert, but Ultra Librarian is always in place. But I will show you probably later more about Ultra Librarian. Okay, so this is the second way how you can create the new part. Another, you can import. You can import massively from Excel, for example, if you have the long Excel table with the new capacitor, something like that. If everything is prepared, can be simply directly imported. I didn't mention that the part numbers what we are using are, of course, our part numbers. So you can see that FC is for FlowCAD capacitor, then some numbers. So this is how we call it, but you are completely free to use your own format. And if you are using already some master system like PLM or SAP, you can simply connect those two words together using an API interface, and we can use your, let's say, numbers what you use, which are you using already in your organization. This is completely no problem. Okay, so now let me switch to the library management. This is the very, very interesting module. I'm convinced about this. It's new on the market, honestly, so I didn't see something like that until now. So, the managing part is quite, this is what I showed you before, managing part is quite easy, because those are just text attributes. You can imagine parts like the Excel table. So not nothing very excited. But the libraries, it's something completely different, because libraries are data, and libraries are data which we cannot change, to write into library data some attributes, for example, like revision, something like that. It's not usually not possible, and very often library are binary files, and we simply cannot work with them as we want. Yeah? So the library management is the solution, which first allows you to simply keep your own libraries in one place. And if you look to the left panel, you see we have PCB, we have PSpice model, we have schematic parts. So everything can be considered as a library. So in OMNYA, for example, we have here schematic parts, and you can see them here. We have some PCB footprints. You can see them here. Okay, so from OMNYA perspective, really doesn't matter what you understand under the term library. It's up to you. Even the documents like PDF files can be considered as a library. Why not? And this is the one thing, that everything can be library. Of course, we are better prepared, better integrate with library. We know, so like footprint from ORCAD or schematic symbol or HDL symbols, then we can provide some previews. We can do more for you. But again, everything else also can be library. So we have support for the Altium, for example. We have some Bambanda SCAN models. Really everything what you like. And this is the one thing. The second thing is, let me collapse the structure. This library, whatever it is automatically synchronized with your local library, usually on your own disk in your own computer. If I switch here to Total Commander, if you see this on the left, this structure, this is exactly what we see here. And something what I cannot probably show you very effectively today, but if there is new library created in library in OMNYA library management, and the library is approved, then the library will be automatically sent to this folder. And everyone who is connected to OMNYA, doesn't matter where the one is sitting, it can be Czech Republic, Poland, Germany, whatever, Australia. After a few seconds, literally after seconds, the part will appear on the local disk. So that's the very big benefit of the OMNYA library management. So if my tools are configured in this way that they see library here locally, I can be sure that my tools are always working with complete and full synchronized, up-to-date library. This is awesome. Nobody is offering this in this way. And now, how to work with this library? So again, what does it mean, manage library? So it means create new, modify existing, remove library from the system. So new library, yeah, I will show you later, but you see here in the table that some of those libraries, they have revision which is higher than 1. For example, this guy here. If I click twice on that, then you see how the library looks at this moment. And also you can see the version, the previous version. Maybe you can see some differences already. Probably you can. But if that would be the large BGA module, that it's not that easy. And every time I would like to check what did change between those two revisions. Of course, we could write it, but write is like sticky notes put on the display. It's better to know. So if the description of the reason of the change revision is not good enough, we can always go to image comparison, and with Analyze we can search graphically for the difference. So this is exactly showing you what did change. Very important thing. Okay, so again, library, they have revisions, and how we deal with revisions, because even here we have two different files, and they have the same name. So what we do, we are sending to the local libraries, always the last revision. So every time I'm working, I will have the very last revision of my library objects. Okay. If you need the old one, for example, I need from the revision 1, I can download this from here, from this interface. It's still possible. So we don't delete old files, we don't overwrite them. They are still available, but not like here in PCB library, where you can see PSM and DRA files for PCB. Okay, so still possible. And now, how we can create the new footprint, for example, footprint, again from the scratch, as I show you already for the parts. It's the same way. You can also use something existing to create new. Of course, we have tools to import also libraries. Usually we do this when we are migrating the current libraries into OMNYA just after selling the tool. Also, this is possible. Okay, so now back to the one part what I have in my system, and I will show you how you can use Ultra Librarian to create footprints, to create or not create, to get for free semantic symbol or footprint. So I have here some parts like this guy, for example. Okay, now this is already defined. So maybe this one. Okay, it's empty. So you see, this is a pending part, and for sure, what is missing here is missing schematic part and footprint. And I need schematic part and footprint because for the release they are mandatory. So I can go here to select from list. As I told you, you can select from the existing library, but not always you have everything in a library already. So you can try, click to Ultra Librarian and look if Ultra Librarian is offering the ready-to-use library for you. And I find something. Then I have to save this footprint in my system. So I have to select the format for the footprint, and you see it's not only Cadence format or Allegro, but we have Mentor, we have Altium. So many of systems are already supported. So simply I have to choose the format, and I will derive a library. Okay, and here I have to select one of the category and create new. Okay. So it took some time because now we are collecting data from Ultra Librarian. We are saving this data on the OMNYA server, not in my workspace, not at this moment, but on the server. Okay. Sometimes it needs several seconds. So okay, now it's downloaded. We see the name. We don't see any image here, and this is correct. So I click OK and save. So what I did, I simply downloaded the necessary data from Ultra Librarian, but still this footprint is not visible. This is what I showed you before. The footprint have to be finished, and what happens? The new request for the new library object has been created in the background automatically. So if I go to, just remember the name of the footprint. If I go to the dashboard, then here on the top in my task, I see the footprint which is waiting for my attention. So I click twice on that. And now I am inside of this footprint. The footprint is still pending, belongs to me. It's my name. And some information are still missing. So no picture, no number of pins. The pins table here is empty. And what I do now, I click on the open. Open is very special button in the OMNYA, because this is something what first download the whole information from server and save this in my workspace, in my local workspace. It's open automatically ORCAD PCB editor, just PCB editor, because maybe I would like to change something here, but I'm fine with this. So I just save and I close this. And yeah, I have to close this. Okay. This is Allegro problem. Wait, maybe I was too fast. So let's do it. And what I have to do more, providing the all changes what I wanted to do were successful. I have to push, but I hope the editor. Okay, sorry, there's something with. Doesn't matter. It happens. Now I will use the push. The push is now the action where all information will be collected from my local disk, and this information will be sent to OMNYA server. So let me click on the push. I hope this ORCAD session, which did not respond, will allow me to do it. Okay, it did something. So this is the list of the files which are going to be sent to the OMNYA server. I can look at this, but let's say I don't want. So just close. Here is PET mentioned. This is very important because sometimes you can create a new footprint and you can forget that you have to send to any system, not only OMNYA. You have to also send PET text to the system, because the footprint is using PET like here with this name. And if you don't send this PET to your library, obviously you will be not able to use this footprint, because it just requires files. So OMNYA is just telling you about this. It's a very important point. OMNYA knows that. OMNYA knows that this footprint is using this PET stack. So close. But what I wanted to show you, this picture has been created. Again, we are working in the web interface still. So this may be very important information for somebody who is not using tools. We have number of pins, which the number has been extracted automatically on the fly for you. When we go to the pin list, we will see the list of the pin, and this all information can be very useful later. So everything what I have to do now, I simply have to approve. To look, and of course I will not able to approve because still I didn't upload this PET stack. I will not do it because we don't have time for that. But the process is I approve once, and then somebody else for me is approving for the second time. And after the second approve, the library, in this case footprint, will be automatically distributed to all users who are connected to OMNYA. Okay, so back to the libraries again, and similarly. Like for parts, you see that some of libraries are used. So this is used. If I go to the where use, it's showing me the list of the project where the footprint is used. So we don't only have where use for the parts, like schematic parts, something like that. No, we were able to show you where the footprint is used. This is also something unique. And the last thing I wanted to talk, the last area are the projects. Projects are what is the definition of project? Are, let's say, containers. So if I show you one like this one, you see I have files. project files. This is obvious. We need some way to store the project files in the system. We have different revisions of the project. So if I click revision 5 and revision 2, you will see all files which belongs to the revision 2 are all files to the revision 5. You can look what did change between those revisions. If these files, if we have only a few files, this is easy, but we have a lot of them, then we can go to file comparison, and the file comparison will tell us what did happen between the revision 2 and revision 5. So you see one file was modified, and we have also two new files also here. So this is how we work with files. But much more important is how we work with bill of materials. Bill of materials are imported from our tools. It's just text bill of materials. So I can simply display the bill of material. I can usually, from every system, every modular system, now I am able to export the board in IPC format. And if I do it, I am able to import the information to the OMNYA. So I have now two things. This is completely independent on which system are you using. So if this is ORCAD Altium, doesn't matter, because every system can output this information. And now I have cross-probing. I can, for example, click for those 4 capacitors, and I see them. I see where they are used. More, I can look for parts with manufacturer part numbers. This is also very useful information. Yes, for example, I have capacitor, and I see all manufacturer part numbers which are listed here. Again, with SiliconExpert and the report. I can also look for the used libraries. Very useful, yes, because again, I told you, we don't have where use only for parts, we have only where use for libraries. So in this view, we are collecting all those information in the common report. So I can look where is the footprint cap 0603 used. So this is very popular footprint, and probably different capacitors with different values are sharing the same footprint, but I see where the footprint is used. This is for footprints. What about flashes, for example? That's a great thing, because we see now that on the design here we have 2 footprints. On those footprints are using PET stacks with this flash. So this is also very useful. So if there is a flash thermal relief which is not designed properly and you have some problems, you can very easily find this even graphically.
I think we're at the end of our webinar. If you have questions, do not hesitate to contact us. And if you want to have a demo session for you personally, please also let us know. We will make it happen. So thank you all for your interest. Have a nice day and see you next time.